Good.
Well, I was going to say that the Capron, as an example, if somebody comes along and says, okay, how do I tackle this problem with the model? As soon as he's done that, even though the model might be crap, he's solved the problem in a sense, because you can see there's a problem with that straight away. And it astonishes me, really, that this wasn't picked up earlier. But, you know, the very discipline of thinking about how to use modelling in this to solve this problem is a great discipline. Now, you may not be using them correctly, that's still a problem.
I think
but to have reached that stage is an advantage.
With Capron, in a way, I mean, the back of an envelope model would have been quite enough to show that...
Even asking the question would have gotten you halfway home.
But with other facilities...
Right, it gets hard.
But may I interrupt in that sense, because, I mean, I completely agree with everything that you're saying, but the truth is that a back of the envelope calculation probably implies a much deeper background knowledge than hitting a key with a computer model. And being able to really make that assessment implies a level of knowledge that I think not only most people don't have in the regulatory process, but I think the truth is that it's not only that, but it's cloaked by the fact that most people actually believe they do understand. They don't understand the complexity and all the levels of the problem, so we're working in an environment where individuals actually truly believe that they understand the complexity of this infrastructure.
I entirely agree with you. I mean, you know, any form of CSV is quite honestly been hanging on about that for years. So I entirely agree with that kind of rubbish that
I think one of the problems that we also have is responsibility of specification writers. And with specification writers, I mean people that are making the standards. They actually sit with a huge responsibility because they are making these standards that we're basing these assumptions of safety upon. And to me, therefore, it's scary with the example I give of the sandwich panels that no questions are being asked from the group that are making this product standard on these panels. They just say, well, the Commission told us to use the SBI test, so we use the SBI testing.
But the question is, those people that are actually making those sandwich panel standards or those sandwich panels themselves, do they actually understand the complexity of why a sandwich panel represents such a problem? I think that's really the key. If you really try to study a sandwich panel, and you mentioned a little bit of this, it's an incredibly complex mixture of structural behavior of the two metallic elements with the insulation, with the joints and the heating regime and all these things, and it's not a trivial problem. So in every single case, we end up in an incredibly complicated problem, but nevertheless, I think the standards are being, or the test methods are being treated in a manner such that they are a little bit like FIRE models. They are basically substitute to knowledge and basically cloak our ignorance. And I think that really is more of a key problem.
Yes.
Yes, talking about this, we have to remember maybe there has been a loss of the main idea of having a standard, or this kind of standard. And it's the safety of people, the safety of the buildings. And I think that nowadays, Europe is, but not Europe, all the international standardization committees are just producing standards for products or for testing and not having or not taking into account safety in all the points. Because if they take into account safety, and if you go to the statistics, then most of the losses or the people who die there, about between the 60 and the 80% is because of smoke or toxicity. And it has not even treated in any kind of European or international committee or standardization committee. So I think that there is these laws in this kind of regulations or regulation groups. Because if they really take care of safety, they should take into account how to control and how to measure and not allow to use those materials that are really risk hazard or toxic ones.
So in the international, in ISO TC92 that I spoke about this morning, there are standards to assess the quality of those products.
Yeah, exactly. There are standards that are for testing this kind of products and to give a certification, but they are not even used for anything. Well, I'm not saying, I'm not right. They are going to be used now with the railway standard, the 45445 or 5445, something like this. But it's quite amazing that in this standard, this railway standard, it will allow to use 6 different methods to control this smoke hazard. And this is nothing compared to this common standardization or this common agreement.
This is an international railway committee,
Yeah,
is it?
yeah.
Formally on
Yeah.
I was just going to ask Christina, were you thinking of controlling the smoke production, the toxic production of materials used in buildings? Because you mentioned vehicles there. I think there's quite a big difference between the two. And vehicles tend to be filled with what they're originally built with, plus people. It sounds like it. Buildings are shells into which you put all sorts of other things.
Yep, in some specific applications, at least for example in tunnels in Spain, they are requiring these smoke standards, this toxicity standard, according to the French regulation. So that's why I try to open-mind it. But even further in the speech that I presented to you, I'm just giving the idea that if we want to develop with this standardization and we want to all work with the same rules, these new standards of the revision of the standard has to be taken, or has to be reviewed, taking into account all different persons involved in fire, not only technicians, but the government and administration, because in most cases, maybe in these kinds of standards, it's not a necessity of having this specific testing standard. If we can get to a conclusion that if we find, or if it's built a building within a specific open areas or with a system to evacuate smoke or smoke production or something like that, and it's part of the engineering, then it would be okay. So, there must be a link and a work together among all these entities to get to proper standards and to avoid the risk of or to promote the safety of buildings and construction.
I'm going to just narrow it to the 2 more comments. So, Bern, you were going to say something?
Just to give the example, what a fire protection controller would have done is analogy to the data protection controller in the drone case. It would have gone, like I do, into the tunnel and asking, when the train stops here now, what's the consequence? And you find out, no emergency, nothing, we cannot go out. Yes?
Ian, and we'll finish.
Yeah, it's actually a statement that Vince made this morning that I found quite surprising. He said that society accepts risk. Accepting means a degree of understanding. Surely the best society in their ignorance tolerates risk. And the people who should be accepting risk on society's behalf are the elected representatives who don't understand risk. And even if they did, it would be politically suicidal to actually stand up and say, we are going to accept a certain number of deaths per year in fire. So, saying we accept risk, I think is actually pushing the boundary a bit too much.
Okay, so with that extremely positive, I would like to end up today thanking you all for a very interesting set of presentations and a very interesting discussion.